We're in association with Wintellect, and we've got Jeffrey Richter today. He's going to be talking about architecting scalable and fault-tolerant Azure storage solution. But first, I've got to tell you a little bit about our great sponsor. Let's see, it is this Pluralsight. Is it Pluralsight? Syncfusion. All right, here we go. Here's our slide. Syncfusion is now our major sponsor, and I believe we're going to be giving away some stuff today. So we also have some other things. I'm going to wait for the next slide to come up. That we want to talk about. This is our contact information for LIDNUG, and we're just getting a new facelift on our LIDNUG site, which is lidnug.org. And let's go on to the next slide, whenever that happens. Our next two meetings are Scalable Signal R applications with Kevin Griffin and Cool Performance Stuff with John Robbins. So those will be great. Let's see. We've already covered the contact information. We've got these two new things coming up. And let's see. We also have a free ticket to, hold on a second, FalafelCon 2014 that Jay wants to give away. And that's, I guess it's on one of these slides. I thought it was coming up. There it is. So there's your discussion right there. I've seen it out there. Anyhow. Okay, so let's go on ahead and introduce Jeffrey Richter. Jeffrey, go ahead and take it from here.
Okay, so I'm going to share my desktop now. Is that correct? Like so. Can you see my desktop? Can anyone confirm that you can see my desktop? Yes. Okay.
Yes. Sorry about that.
I'm sure it'll scale down okay.
Okay, so everything is fine on my end. I can start talking?
Yes, indeed.
Okay, great. All right. Well, thank you, everybody, for joining me here. So I'll just do a quick introduction, then I'll get into the content of the talk. So this course or this session is brought to you by Wintellect. We are a company that's been in business for about 15 years now, offering consulting and training services for a really long time to Microsoft and a lot of other companies as well. I am the person who's presenting this talk. I'm Jeffrey Richter, one of the co-founders of Wintellect, and I'm a software architect, consultant, instructor, and author. On this slide, I show the book covers of my 3 most recent books, but I have about 18 books now written over the past 22 or so years. On the far right is my Windows VSC C++ book, which is currently in its 5th edition. That was last updated for Windows Vista, and I doubt very much that I will ever update that book again. Then in the middle is my CLR via C# book. That's currently in its 4th edition. That came out a little bit over a year, maybe a year and a half ago, and it was updated for .NET 4.5 and Visual Studio 2012. And then on the far left is my most recent book, Windows Runtime via C#, and that book just came out a couple months ago. And it's for people who are using C# to talk to the Windows Runtime APIs to build either Windows Store apps and now also Windows Phone apps as well, using the universal application model that Microsoft introduced with Visual Studio 2013. Below that, this is just to say that I will accept any friend requests from anybody on Facebook, Google+, Twitter, or LinkedIn. So if you want to find me on any of those services and request to be a friend of mine or associate, then I will accept that. Below that is the link to the Wintellect blog, where I and other Wintellect people periodically post blogs about technical things. In fact, in the past couple of weeks, I've put about 3 blog posts up there on various topics. and I have some more that are in the works. In fact, I'd like to take this session here that I'm about to do and ultimately turn it into a series of blog posts as well. And then below that is my email address, where you're welcome to email me if you would like, if you have any questions or want to talk to me about something, at jeffreyr@wintelect.com. The only thing I ask is for people, please, to not send source code and then say, can you help me find the bug? Wintelect has consulting services for that, and we enter into a contract for that. But if it's just a quick question here or there, then that's perfectly fine. Way to go. I don't mind email on that. About a year and a half ago, Wintelect introduced its newest service called Wintelect Now, and it's available at wintelectnow.com. And what we decided to do is take all the training that we've been doing over the past several decades and record it and offer it as a subscription service to people. So I would encourage you to go and check it out. If you register with this code here, Jeffrey R-2013, then you'll have 14 free days access to every video that's in the entire library. We're always increasing the size of our library with new content all the time. And we're also looking for authors. So if you are a subject matter expert in something and you would like to make a passive revenue royalty stream, then over the course of a weekend, you could record a video session for us. We host it here on the site, and then every quarter we pay royalties out based on the number of views that your video has watched. We also give you free access to the library in perpetuity and some other benefits as well. So if that's interesting to you, then you can contact me, and then I can put you in touch with the right people to make that happen.
Yeah. Sorry to interrupt, but can you bring your screen resolution down a little bit? A lot of the text on that previous slide's cut off at the right.
Yeah, sure, I can do that. So let me go.
Especially the code that you gave away.
Okay, fine. So let me go down to maybe 1280 by 720. Let me say okay. I'll keep these settings. And back here to PowerPoint. So does this look better now?
Much better. We can see the whole desktop now.
Okay, great. So there's the code, Jeffrey R-2013. And feel free to share this with other people as well. We need as many people using the service as possible, and any word of mouth that we can get, we greatly appreciate. Okay, thanks for letting me know. I've been working with Azure now for over 4 years, and I've been doing a lot of work with it. I mean, almost every day of my life. I've been working with it, either helping with our consulting division trying to migrate customers over to Azure, or I've been building Azure projects of our own. In fact, the Wintelect Now website, the back end of it is built by me, and the front end was built by some other people. And the whole back end of it, if the whole thing runs on Azure, and the whole back end of it communicates with Azure Storage. So I have a lot of experience working with that. And while I've been working with Azure Storage over the past several years, I've come to learn some patterns and practices that are good, and also patterns and practices that are bad. And I ultimately decided to create a guide, like a white paper, if you will, about working with Azure Storage. And I call Jeffrey Richter's Guide to Working with Azure Storage Tables, because it just focuses on tables, because that's where I think the most guidance is needed for people. And then I do most of my programming, almost all of it, in C#. But everything in here would also apply to other .NET languages as well. So this guide has actually been reviewed by Microsoft's Azure Storage team and is endorsed by them as well. And to their credit, I say a lot of things in this guide that's actually pretty critical of some of their client library that they recommend that programmers use for accessing tables, and they agree with some of the negative criticism that's in there, and like some of the suggestions that I give in my document for how to work with tables in a better fashion. So the way that you can download the document is go to this website over here, bit.go, Richter Tables, and by the way, this is case sensitive, so everything is lowercase except the R and the T. That must be uppercase. Then we ask you to put in an email address so that we can contact you in the future, but you can opt out of that. And then you'll be downloading a PDF file that has this document in it. Now, the guide's purpose is to offer several things. The first is to help developers improve their mental model with respect to working with Azure Tables. So if you're just working with Azure Tables as a NoSQL store, I give a lot of tips and tricks in this document for how you can think about it in your head and how you can really leverage its features. I think the table service itself is incredible, and I think it offers a lot of features, and programmers who are working with it, especially ones who are relatively new to working with a NoSQL database, are not really using the tables to their fullest advantage. Things like versioning without having any downtime to the table, and performance characteristics, and using entity group transactions to perform transacted operations over a set of rows in the table or entities in the table. There's a lot of things that people just don't realize that the feature set is there, and then how you have to architect or design your table in order to take the most advantage of these features and to get the most performance and scalability. Also, my document talks a lot about costs too, and how to minimize costs when accessing the table in terms of both storage and in terms of making I/O requests against the table. So anyway, there's a lot of, I think, really good information in this document. So another thing in this document or the guide is I discuss the good and the bad parts of Microsoft's Azure Storage Library. The storage library has a really good core foundation to it, and then it has some abstractions on top, which I actually think are not that good. And then I explain in the document why some of these abstractions are not that good and why they should be avoided. And I give numerous examples for that. So that if you are using tables, using Microsoft's client library, the document should be really good to give you things that you should gravitate towards and things you should gravitate away from. I also want to show good patterns and practices related to tables, and I do that in this document too, to say, here's things that you should really be keeping in mind, like how to do segmented queries against a table, so that you're, making requests in an efficient fashion and you're processing the data in an efficient fashion, using memory in an efficient way. I also talk about optimistic concurrency patterns too, so that there's no data corruption, and why that's such a useful thing to know about and really integrate pervasively throughout your code base, which we have done in the WinElect Now code base. And then, since I've been working with Azure Tables for so long, I have created my own Azure Storage Library that is built on top of Microsoft's, and it's free. I don't charge for it at all, and it's a NuGet package that from Visual Studio you can download my NuGet package and make it part of your project. And it includes a lot of features, many of which I'll be talking about how we use them as I go through the rest of this presentation. So in particular, I have a bunch of features related to blobs in Azure, such as this whole logging infrastructure, which actually is not fully part of the library yet. So we're still doing some internal testing with this and making sure that it works properly and it scales well and so on. But we feel really confident with it. And it should be part of that library, I don't know, maybe within the next month or so. And then there's another part that's related to blobs called the periodic elector. This is also a really important part of the library. We use it a lot in WinElect Now, and I'll show slides later on where this periodic elector really comes into play for us. And just having this available as a reusable tool has made it very easy to build new websites based on Azure Storage and just add features very quickly. Then there's a lot of features in my library related to working with Azure Tables. One of the big important ones is backup and restore, and I'll be talking a lot more about that closer to the end of this presentation when I want to talk about things like fault tolerance and disaster recovery, and how to protect your data from hackers or from a rogue employee who you might want to fire or leaves or gets angry for some reason or another. The optimistic concurrency, again, very important part. If you look at our code base, you would see that it is littered with this optimistic concurrency code to make sure that no data corruption occurs when talking to the storage system. And in fact, what happened was I wrote the code so many times over and over and over again that I decided to put it into this library as a reusable generic component. And now it's really easy for me to add the optimistic concurrency support throughout the rest of my code base. It's basically just one line of code. I also have some helpers in here for doing easy filter construction. if you want to make a filtered query against the table. I have some helper classes in here to make it really simple to do segmented result processing when you're querying results off the table and you're processing the results as they come in. If you want to go and modify properties on a table, maybe replace one property with another, maybe just change its name, or maybe you want to remove a property from the table because it's old and you don't need it anymore, then I have some helper code in here that's a property replacer and changer. I recommend some patterns for how to create extensible entity schemas where over time you're able to modify the schemas, but your .NET classes can also change dynamically over time too. So it's a really nice pattern for how you can change the patterns in the table for some new entities, change the schema in the table for new entities, but leave the schema alone for the old entities, but then have a .NET class that handles all of that. There's also some patterns where, let's say you have a property that's a Boolean, then you decide later that you want to change it to an integer, or change a property from one type to another. I also show some patterns in this document how to make that easy to do as well. And sometimes there's places where you want to take a bunch of information and just serialize it out to a single property into a table. And so my document and my library give examples of where this is useful, and the library demonstrates how you can write some code that, with very little code, you can take a collection of, book chapters or game scores or whatever it happens to be, and then serialize it into a highly compressed binary fashion, and then write that out to a property or possibly set of properties that are inside a table. And we have examples a little bit as I go through this discussion where we're using this too. So there's just a lot of patterns and practices and good examples of things to follow that's in here. That's not specific to Wintellect Now, but I'm using Wintellect Now as our website as the way that motivated a lot of these things. And then at the very bottom here, I give the link where you can go to download this NuGet package and make it part of your own projects if you desire. All right, so now I do want to talk a little bit about the architecture of Wintellect Now. Oh, and let me say one thing. I will periodically look at the Q&A manager over here to see if anybody has any questions over here. So feel free. And actually, I think this talk goes really well if it were more interactive. So it's kind of a shame we're not in a live classroom with you sitting in front of me. But the best we can do is this Q&A manager. And so feel free to ask questions, because there was a lot of thought given to everything that I'm presenting in here, number one. Number two, not only was there just a lot of thought from me on this, but this has been reviewed by the Azure Storage team as well. And so their feedback and suggestions have been integrated into it, and all of the rationale as to why we did things one way versus another way is what we can talk about. If you raise some questions, I'm happy to go into it in more detail. So this slide here is the overall architecture of the Wintellect Now website. It's not all the varied bits and pieces, but it's the most important pieces of it. So if you're not familiar, Wintellect Now is an online video library with technical content for software developers. And we have a bunch of virtual machines running as in Windows Azure, Microsoft Azure as it's called now, using their cloud service. And then we have all of our data that is residing in Azure Storage up in some data centers in Azure. So whenever the virtual machines boot up with our website code on them, one of the things that they do during boot time is they read this XML file called videolibrary.xml. This file is in blob storage in Azure. As I say here on the slide, the XML file is read at boot, and what it contains is our entire library with all the videos, all the descriptions, all the the subsections of each video. All of that information is stored in this one XML file. And each virtual machine rereads this file from blob storage every 5 minutes. So the reason for this is because we are constantly adding new content to the library, which means we have somebody working at their desk at home. They get some new videos from authors. The videos get uploaded. We modify this XML file. And actually what we do there is we actually keep all this data in an Excel spreadsheet. And then we have a tool that parses the contents of the Excel spreadsheet, and then it produces this XML file. Then the XML file gets uploaded into blob storage, and the virtual machines, every 5 minutes, they reread the XML file. They do a timestamp check on it, so they only actually reread the contents if the file is newer than what they read last time. So if the content is newer, then they download it, and then the VMs now have all the information about the updates to the library. So it's done every 5 minutes because we want to get any new videos that we post to the website. We want to get them viewable by people, as quickly as possible. So as soon as we post a video, within 5 minutes, it should be available on the library for people to go and see it. And each virtual machine has its own deserialized version of this XML file, and that remains on each machine. So as users like yourself are navigating our library and looking up what videos are available and doing sorts, all that information is happening right on the virtual machines themselves, and so it gives very high performance to this. Now, we also have another file called IP to country CSV. This is a comma-separated file, and this file contains basically IP addresses to country mappings. We charge people who live in certain parts of the world, like India, a reduced fee when accessing the library. And so when people log into the service, we get their IP address, and then we need to know what country they're in to see if they're paying this reduced amount. And then if they are paying the reduced amount, they're only allowed to watch videos when they are within that particular country. So one thing that we considered when designing this was to leverage an IP to country service, so that whenever a client request comes in, we get their IP address, and then we would make a request to another service to find out what country that they are in. But I quickly discarded that solution for a couple reasons. One is we want people to log in, and when you want to watch a video, by the way, when you watch a video, we also have to check your IP address to make sure you're within one of these countries where we're giving you this reduced fee to. We don't want you to pay the reduced fee and then travel to, let's say, the United States and be able to watch things in the video at a reduced cost. So whenever you're watching a video, we also check your IP address to make sure that you're in the right, in the reduced pricing country. So if we had used a service for this, that meant that every time you wanted to watch a video, we would be making a request to another service, and that would hurt latency and performance. And if you want to watch videos, we want to make that as fast an experience as possible, so you're watching the video, really fast. Another reason why we didn't want to use a service is because that service might go down. And if that service goes down, then if we can't look up an IP address to country, then what are we going to do? And we could just say, well, just watch the video anyway, or we could potentially block you. And block you, we figured customers would consider that a very negative experience. And so we didn't want to do that. And we didn't really just want to let you watch anything either if you're not paying for the whole service. And so what we decided to do is we periodically get this IP to country CSV file, we download it, we put it in blob storage once again, and then all the virtual machines, they reread this file once per day, which seems to be plenty actually, because it doesn't, the information in here doesn't change that much. Because each of our virtual machines running in the cloud and the data center has a copy of this, whenever you try to watch a video, we can just get your IP address, immediately look it up in the table to see if you're in one of these reduced countries. We have no dependency on another service at all, so the performance is fast. If the service goes down, we're immune to that. And this was, I think, a much better architecture to go with. And then, as I say, we reread this daily. And, if something causes us to not update it periodically after a change, it's mostly okay. So we feel like this is not the kind of information that has to be totally up to date, super, super critical, unlike the video library, where we want that updated very quickly so people can watch new videos as soon as they become available. Another table that we have in Azure is a promotional code table. We let people register with the service using various promotion codes. A lot of times we create these promotional codes for events like TechEd or the Build conference. And then when people use them, we want to be able to keep a record of how many times a promotional code was used. Then we could say, well, we got a lot of people who registered at a TechEd event, so we should be at TechEds more often. Or we didn't get very many people who registered at some other event, so maybe that event isn't worthwhile for us to, advertise in the future. So we have a table that has an entry with all the promo codes in it, and whenever somebody registers, we have to go to this table, look up the promo code to make sure it's a legitimate one. We also let people use when we create a promo code, it has a maximum number of usage, like only 1,000 people can register with that code. That way, some codes we don't want to get them to be abused too much. So all this information is in this table, and we look them up. And that table's really only used when people are registering on the system. So it's only a slight perf hit during registration time, and it isn't used. Once you have an account on the system, then we don't use this code table anymore. We also have another table in Azure, which is our video statistics table. And whenever somebody is watching a video, as you are watching it, the browser is constantly notifying our server who's watching which video and at what position you're at in the video. And we have a video statistics table in Azure that has one row in it for every table that's part of our library. And it keeps track of how many views a video has watched. And then we look at this every quarter so that we can pay the royalties out to the authors of those videos so we know how much to pay them. We can also look at it and see what kind of topics people are interested in. Videos that are being watched a lot, well, on certain topics, we say, well, we should build up our library with more topics in that area. So it's a really nice cycle that we can see what things people care about, and then we can build up more content and acquire more content in similar areas because that's what people seem to care about. Now, the main part of the service are you, the users. And when you log in, we have a user table. Well, when you register with the system, we have a user table in Azure, and that has one row in it for every user who has registered with the system. And whenever you're logging into the system, you put in your email address and a password, and then we go into this table and we look you up to see if you're actually in there. And if you're in there, then we know who you are, and you are authenticated. Now, a user has some other things that are associated with them, like which videos you have watched. We keep a record of all the videos that you have watched on the system. We know on the date that you last watched a particular video. We also keep a timestamp from where you were in that video. So if you ever go back to the page to watch that video again, we know where you last left off. And then if you hit play, it'll just continue from the last place that you were last time you were watching that video. And we don't have ratings right now, but this is a feature that we want to add. And so you'll be able to rate videos, and that will go into this watch video table as well, what your ratings are for each of the videos. And because we're using Azure Tables, which is a NoSQL store, it's just really easy for us to add properties like a ratings property over time. And people who've watched videos in the past where there was no ratings property, it just won't be there. And people who watch videos in the future, once we add the ratings property, then that property will be there. And it works great, and that's why I'm such a really big fan of NoSQL stores. We have another table, which is a bookmarks table. As you're watching videos, you are able to bookmark them at certain positions within a video and then make a little note or memo about that. And then you'll be able to go back later to a video and say, somewhere in this video is where Jeff talked about, whatever, and that was interesting to me. And then you can click on the bookmark, and it will take you back to that video, and it has the location within the video, and then it can start playing from there. So we have another table in Azure that keeps all that bookmark information. And I'm going to go into more detail about how these tables are actually structured internally. And then the last thing we have for a user is a queue container. So this is actually a blob container, and within that container we have one blob per user, and that blob contains in it your user queue. Every user has a queue, and this is where you can insert videos that you would like to watch in the future. Like, I want to watch this one, then after that I want to watch this next one. If you're familiar with Netflix, it's similar to your queue in Netflix, which are a bunch of videos that you thought were interesting and you would like to watch them in the future. Now, your user queue, you can delete things from it, you can add things to it, you can reorder the videos that are inside it. And we save that into blob storage for each user. There's one blob for each user, as I say. And again, I'll talk more about these things in detail as I go, and some of the trade-offs in the thinking behind whether we designed it one way or another way. Now, we have another table, which is the account table. And the account, the best way to think of it is it's a unit of billing. So when you register with the system, we create an entry for you in the user table, but we also create an entry for you in the account table. And you can specify how you want us to bill you. So we currently support, you can be free under a promotional code for 14 days, for example. So that's one kind of account. Or you can use PayPal to be paying for your subscription each month. We also support Stripe for doing credit card purchases, and we'll just bill you your credit card each month. We also have some customers, like corporate customers, where they pay with a purchase order. So they just write us a check directly. And we have this one account table in it, and inside here we have the account and the billing information for each account. And again, I'll talk more about this as we get a little bit further down into the discussion. But accounts have administrators, and you can have one or more users who are administrators on an account. And then they can change the billing type, for an example, right? An administrator can change how the billing happens. Another thing that accounts have are grantees. So this is more for our corporate customers, not for the individuals, but we have some companies that basically set up an account with us, and they are buying maybe 25 seats. And then they will put various employees at the company in and out of those seats over their period of time, over each month. So the employees, they would register themselves on the system as users. We would have an account set up for the company, and then an administrator of the account can put users up to 25 in and out of the seats in that account. So administrators, they can change the billing. They can also change how many seats they're paying for each month. Maybe they want only 5 seats, but they hire some new employees, so they want to go to 20 seats. And they can also put their employees or our users on our system in and out of those seats over the period of time. So that's what an account is for, kind of a unit of billing. It has administrators on the account, and the account also has grantees of the account, people who are allowed to watch videos. Again, I'll talk about it more as we go on. Now, another thing that happened is that as we were building the system, we had customers that wanted to be able to get logging information. So the past month, the common one is, over the past month, what have been washed? And then we also do logging for errors. I have exception that occurs on our site. We, of course, need to log that so we can fix it and improve the quality of the site over time. We also want to keep track of all the people who have registered using a particular promotional code. And we also have account management operations that we want to log. So since an account can have multiple administrators on the account, one administrator might put somebody into a seat, another administrator might eject someone from a seat. So some administrator might want to say, hey, I just put this person in, who ejected the person out? And they would want to be able to see that information. So this started off as something that we didn't think we would need a lot of, but over time, we are coming up with more and more reasons why logging of events is really popular. So what we've ultimately done is we've created this whole logging infrastructure now. And the code for that will eventually be in my NuGet package library, but it's not there just yet because, as I said, we're doing some more testing with it. But we have identified 2 different kinds of logs. The first kind of log is an ongoing log, which is really a blob in Azure Storage. And then whenever some event occurs in the system that we just want to remember this for future, we just go to the blob in Azure Storage and we add an entry to the end of the blob. And it just keeps growing indefinitely without end. And all of our virtual machines that are executing our code are able to append entries into this blob, these ongoing logs or blobs. Then we have identified these other kinds of logging that we do, which is periodic. Typically, it's done based on a billing cycle. So for account user watching, for example, that is when an administrator wants to see which users that they're granting access to have watched videos, we create a blob for that, and it's 1 blob per month. And that month is tied to their billing cycle. So then when a billing cycle is finished, they can download that blob from us, and then they could load it up into, let's say, Microsoft Excel or some other tool or utility, because we're just creating CSV files. And then using a tool like Excel, they can produce graphs and charts and so on to see on this date, this person watched this video, and this is the percentage completion that they are. And they can see what the return on investment is for using our service. We also use periodic logs for error handling. So whenever an unhandled exception occurs, we write that out to a blob, and we use one blob per day. And then we hope when we look, there are certain days when there's no blobs at all, which means no unhandled exception has even occurred that day. So then when customers might call us up and say, hey, we've noticed we had a problem with the website, we can say on what day did that occur. Then we can go directly to that blob in Azure Storage, download it, and that's where we have all the unhandled exceptions that occurred that day. They can tell us maybe what time. We can see exactly what went wrong in the service, then try to backtrack from that, fix the code, and deploy a new version of the code. So this has been incredibly useful for us. One other thing I'll add about the periodic logs is that they support this feature, which I'm referring to as garbage collection. And what that means is whenever new log blobs are being created in the service will look to see if there's any similar blobs that are older than some certain time frame. And then it will just automatically delete them. For example, we keep up to like 6 months of video watching history for any given account. So if you're going into your 7th month, the old log, we want to go and destroy that, because if these blobs, they just sit in the storage service indefinitely, then you are paying for them month after month after month for having that memory data just sitting there in the service. So the periodic log infrastructure has this garbage collection part to it, where you can give it expiration dates, and whenever it creates a new blob, it looks at old blobs, and if there's any older than the expiration date, it automatically destroys them. And this just ensures that our costs don't go out of control, because it's automatically deleting data that's too old. Let me pause and see if there's any questions here. How do you handle with people, i.e. fake IPs? Well, we look at the IP address that's coming in. So we don't do anything special right now. I mean, we have given a lot of thought to ways that the system can be abused, and we understand that the system can be abused. One way is one person pays each month to watch videos, and then at the lunch break, 10 people at the company goes into a conference room, and they all watch videos under that one person's account. And, clearly with that, there's nothing we can do to stop it. There's also nothing to stop somebody from maybe, putting a camcorder on their video screen and then just recording the sessions. So we understand and appreciate that the system can be abused in its current state. We hope that most people are honest with the system, and we are monitoring things, and then we're seeing what we would need to do in order to protect for certain things. So one thing that we don't have quite yet is for each user to keep track of what IP addresses they use when coming into the system. And if we see a lot of different IP addresses in a short period of time, then most likely other people are logging on with the same account. And then we can do some things to mitigate that. Right now, we haven't felt that people have been abusing the system. And so we have ideas for things that we can do if we notice the actual abuse. Sometimes the cure is worse than the disease. So the amount of code it would take to track all of this stuff, to test all that code, to monitor it all, is pretty substantial. And so we really don't want to do it unless we detect that abuse is occurring. But these are the kinds of questions that we ask ourselves when architecting the system. So could the system be abused? Yes, it could. How many people do we think we will do that? Hopefully nobody. So let's put some things in place to monitor it, and let's not try to actually fix it until we notice it's an actual problem. Another question is, why couldn't you make it so that all VMs would read the IP to country only when it was actually modified? Send like a push notification to all VMs to read it. That's a good question. The reason why we can't do that is because Azure Storage doesn't support that. Azure Storage is a RESTful service, and you make HTTP requests into it, and it gives you a reply back out. There's no way for you to register, for example, a callback with the service so that when something changed, it would go and notify all the VMs. So the VMs must periodically poll Azure Storage. Great question there, too. Anybody else have anything you'd like to ask? Okay. Now, we also leverage many other services, too. For example, the actual videos are uploaded to another service where they are transcoded into different bandwidths, and then that service is connected to a content delivery network so that the videos get streamed very quickly anywhere around the globe. We have payment services, like I mentioned, PayPal and Stripe, that we are using in order to do payments and credit card authorizations. We have an email service that we use, so when you register with the system, we send an email out to you saying, thank you for joining the system. And when your promotional period is expired, we send an email out saying your promotion's expiring, please pay. Or if your credit card is expiring, we send emails out for that reason too. And many other places on the site where we send emails out to people. We use another service for user support. So if people are having some problem with the service or have a question, they can go and click and enter that in, and that comes back to us, and then we have human beings who can respond to those things. And then when you're watching a video, we have forum support there, so that can encourage people to have discussions about a video and make comments on it. And these are all services that we have not built ourselves. They're all services that we somehow leverage in some way. Whenever we're thinking about using some other service, there are many, many, many questions that we ask ourselves. One of them, of course, is, how robust do we think this service is? Is it really going to be staying up and running? Now, our video service, that is critically important to the success of our platform. If people are unable to watch videos for some reason, then the whole service completely falls apart. So we spend a lot of time and effort, researching a video service provider with a content delivery network, so the performance is good, the streaming is good. Of course, we have to consider the cost of that, what it's going to take us to run the service at these costs, and latency issues and so on. For a payment service, that's really not as critical. It has to work, of course, but usually the payment thing only happens once a month for every customer. Some customers even prepay a year in advance for the service, in which case we give them a discount. So if for some reason our server can't reach Stripe or PayPal in order to do payment processing, it's not necessarily the end of the world. We can give our customers a grace period, and then we can try again in a day or two. So, again, these are the kinds of things we think about, and the latency of hitting this service, the frequency that we're hitting this service, the cost associated with the service, and the resiliency of the service. Email is another one where if we're unable to send email right now because that service is down or having a problem for some reason, and then the email gets sent out a day later, again, we don't think that is super critical in most of the scenarios within our service. User support, obviously we'll want people to be able to contact us if they're experiencing a problem with the site, and that is probably more important to us than some of the other things because we know that users will be frustrated if they can't get help when they need it. And the forum support, we consider to be a nice-to-have thing. Initially, when we launched the service, we did not have forum support at all, so people were just watching videos, but there was no way to discuss any video. If, for whatever reason, our forum support went down for a day or two, again, I don't think it's the end of the world. Whereas, the example I gave earlier about the IP to country, if we used a service for that, and that went down, and people couldn't log in or people couldn't watch videos, that is horrible to us, which is why we basically snapshot the IP to country database in the CSV file, and then each machine reads it and has it locally to do the fast lookup. So we have no dependency on the other service at all, and the lookup is blazingly fast, so people can get access to what they're paying for as quickly as possible. Those are the things or trade-offs that we keep in mind when designing any of these things. Let's see, there's another question here. I'm planning to write another book. Not right at this time. If I do, the Windows Runtime book just came out a couple months ago, so that one's relatively new. And any other books I write would be based on new versions of technology. So perhaps when the next version of .NET comes out, I would revise my book. I don't know if I would write a new book from scratch. We'll see. All right, so if we look a little bit deeper into the architecture of the system here, this is what our user table looks like. And the partition key is basically your email address. So when you log into the system, you're logging in using your email address and a password, and then we need to look you up as fast as possible. So in order to do that lookup so that you can log in really fast, we immediately go into this user table, and we do a search in the table for partition key equals your email address. And the row key is just an empty string. We don't actually use the row key in this user table at all. So this is the very fastest way that we can possibly look somebody up. Now, once we've looked you up, I mean, obviously, if we don't find your email address, then you're not, a registered person on our system. So we can find that out also very quickly, too. But if we find your row in the user table here, then what we get back is a user ID. This user ID is effectively a GUID that we use to uniquely identify you within the system. And it's the key for other parts of the system. For example, when you have your queue, your user queue, where we keep a record of here of all the videos that you want to have in your queue, I told you earlier that we keep that as a blob, one blob for each user. Well, the name of that blob is based off of your user ID, not off of your email. The reason for that is we want to allow you to change your email. And if you change your email, then the name of the blob would have to change too. So we didn't want to have to keep all of that stuff in sync. So when we create a user entry for you in this table, we get a GUID that uniquely identifies you. That GUID is what we use as the key for all the other information related to you in the system. So if you ever change your username in the future, your email address in the future, then everything else, we're still able to find it by using this unique ID, and we don't have to keep everything else in sync. Also in the user table, we have a property called admin of and another property called grantee of. You may be the administrator of one or more accounts. And so we have one property called admin of, but what's in that property is basically it's a byte array property, and it's a serialized, comma-separated list of account IDs. So this indicates which accounts you are the administrator of. And the grantee of it's a one property in the table, and it has in that property a list of all the accounts that you might be a grantee of. So you're able to watch videos using any of these accounts, and then we know which accounts to build other information against. Well, that brings us to the account table. The account table, again, the account we think of as a unit of billing, and it has a partition key, which is the account ID. And the account ID is also basically a GUID as well. So that means it never changes. It's a static value. And the row key is the empty string. We have an admin's property, which is a comma-separated list of email addresses. So if I have an account, I can find which users are the admins. And there's a grantees property that's also also. So if I have an account, I can see which users are the videos that should be charged to this account. And then there's some payment properties. Now, the payment properties, I think, is actually a really interesting thing. And again, one of the cool parts about using a NoSQL database. If you look at the bottom of this slide, we have in our C# source code an abstract base class called account. And this base class has some prominent properties for all different kinds of accounts. Like it would have the account ID in there, and it has the admin's property, which is this collection of emails, and it has the grantee property, which is the collection of emails for the grantees. All accounts have that information in it. But then, as I was saying earlier, we have some people who pay by credit card. So we have a credit card account class that is derived from the account base class, and it adds some additional properties that are specific for credit cards. By the way, just for the record, we never store credit card information like your credit card number or expiration date. We don't store that at all. Period. Anywhere in our site. So if our site ever got hacked or compromised in any way, we do not actually have any of your credit card information. We have some information to record that you are a credit card. You're paying for the service by using a credit card, but we don't actually keep the credit card information in our site. We've actually had security reviews of our site too, and it's all locked up pretty tight. Like the most thing that anybody could steal are what videos you have watched. But we do a lot of things to protect that information as well. we have some people who are paying possibly with direct debit. We actually don't support this today, but it's possible we could do it in the future. So we could have another class called direct debit account, also derived from the same account base class, and then we might have some additional information in here that's related to direct debit people. And then we have another class, like purchase order account, that's derived from the base class account, and then it would have additional properties on it for purchase order. Now, I mean, in the real service, we have like promotional accounts, and we have purchase order accounts. We have some customers that actually pay with seat months, which is a completely different billing model. We have people paying with a Stripe account. We have people paying with a PayPal account. So in the actual service, we do have an account-based class, and we do have many classes that are derived off of that. And in fact, the hierarchy is actually much deeper. In some cases, we have like a subscription account, and derived off of that is PayPal and Stripe, for example. So one of the great things about this architecture, though, is that you have this in .NET, this C# base class account that has properties that are common to all accounts, and then we have this inheritance hierarchy where we introduce new properties specific to a particular type of account. Then what we need to do is we need to take these account objects that are in memory, and we need to put them into the account table. And because it's a NoSQL database, the table, not all of the entries in the table have to have the same schema. So some of the entries in the table are credit card accounts, and some of the rows in the table are direct debit accounts, and some of the rows in the table are purchase order accounts. And they all have different properties on them. And then when we need to go and deserialize an account, we look up the accounts in the table. We can look at one property is common across all the accounts. It tells us what account type it is. Then we know what kind of C# class to create an instance of. And then that C# class, which is one of the ones I show here on the bottom of the slide, is now the type safety wrapper over the information that's in that entry in the table. And this works out phenomenally well for us. We get a lot of versioning, and people can even change account types. If they can go from direct debit to purchase order, for example, what we'll do is we will replace that entity on the table with the new account type, but it'll have the same account ID on it. And we can just copy over all the admin information and all the grantee information. So going from one account type to another is really super simple for us, really easy programmatically. It's also super fast, too. And we have this really nice programming model that in our code, we know what these different accounts are. They're different derived classes with different methods on them. So it's just a really great programming model, and it's a great way to store the data as well in a very efficient fashion. Let me see what other questions may have shown up here. If you're using ID as a user ID as a unique identifier for everything on the system, why use the email as a partition key? Is it just speed purposes? That's a great question. And here's the reason for that. The way that our system works with corporate enterprises is that a person at a company, a manager at a company, can go and purchase an account, and let's say they're buying 25 seat months, right? So they're buying 25 seats per month. And then that person at the company says, well, I have an employee, and I want to go and put them into a seat. Well, that employee may never have registered with our system yet. It could be that the manager just wants to put them into a seat, but they've never actually registered with our system. Because they've never registered with our system, we don't know about them yet. And so we don't have a user ID for them. So the manager will go and put in their email address of this employee. And that's why we use email addresses for the admins and the grantees, because the email address will identify this person, even though the rest of the system doesn't actually know who they are. And then we can send an email on behalf of the manager. We can send an email to that person saying, hey, the manager has just put you into a seat, but you need to register with us before you can start watching videos. And then there's a link that's included in that email. The person receiving can then click on that link. It goes to the website, it registers them, and then it attaches them to the account. So now that person is able to watch videos. There's enough information in the link that we send them that when they click on it, we register them, we attach them back to the account, and then they're able to watch videos at that time. So this is why we use email addresses instead of user IDs. In addition, an administrator of an account might want to say, well, what are the grantees that are in the seats right now? I want to know the email addresses of all the people who are in the seats. Well, if we had used user IDs for this, then we would have to go back to the user table for each user ID, look that up, which isn't a fast lookup because the user ID is not the partition key. So it would be a table scan to look them up by user ID. So it would be it would be slow performance doing that. And we would also be making a lot of I/O requests because for every grantee, we would have to scan the table looking them up one at a time. So by having the list of emails here, we can simply populate our web front end and say, here are the email addresses that are in seats. And we don't have to look up the individual users at all. Now, if the administrator goes and adds somebody or removes somebody, then we can go to the table and then modify that one person that they're adding or removing. But that's a great question, and that's the reason why we don't use user IDs in the account table. The account table has the email addresses, but the user ID is everything about the user itself. How can I guarantee to the user that we don't have access to your credit card information? I think you mean how can I guarantee to the user we don't have access to your credit card information? Well, if you are registering with the system and using PayPal, then our website takes you directly to the PayPal website. So it's not even our website. You're putting that information and you are authenticating with PayPal. So the only way we could even get it is if PayPal somehow returns it to us. But of course, PayPal doesn't do that because the PayPal service itself knows that this is secure information and that our website should not even have it. So PayPal does give us back some IDs to identify you, but it's not your credit card numbers or expiration or anything like that. And then we keep those IDs in our system so that we can, go back to PayPal and correlate things later if necessary. It's similar for Stripe as well. When you're putting in your credit card information this way, you're really doing that on a Stripe form. You're not doing that on our website. And so once again, we don't have this information. It's never even given to us. So therefore, we don't store it anywhere. Is the user table used for authentication, and if so, our password store, and if so, encrypted? The user table is used for authentication, and when you put in a password, we hash it immediately, and then it's the hashed version that is stored in the user table. In fact, the hashing is done very early on, so we don't even pass passwords around the system ourselves in case there was a compromise in the system. So we never store passwords ever, anywhere. We do store a hashing of the password somewhere, and then we also do a similar thing with hashing passwords if you reset your password, because you're able to reset your password should you forget it. Okay, so those are the questions that are there. So I'll move on to the next thing. So the next part of our storage architecture is the watch to video table. So as I mentioned, we have a table, and this is where we store all the videos that you have watched. As you can see, the partition key is the user ID. So that's the GUID that uniquely identifies you. So even if you change your email at some point in the future, we're still able to look up what videos you have watched in the past. Now, the row key for this table is the video ID. So we actually have one entity in this table for each video that you have watched. And then what we store is the timestamp, last time you watched that video, the offset in seconds within that video where you last left off. That way we can restore you, if you've watched 30 minutes of the video, we know that. And so when you hit play, we'll start you at 30 minutes in. And then we also keep a minutes watch, so we know how many minutes of that video you have watched. Administrators like this because they want to know what percentage of a video a person has watched. If they're paying for it. Now, because the table is architected like this, we get a lot of really great things. First is it's all grouped by user. So if we want to show you in the user interface what are all the videos you have ever watched, we can simply go to the table and say, table, give me everything watched with this user ID. And then it will return everything right back to us. And it does it, it's the fastest way possible to do a lookup in the table. If you go to a specific video, and we need to know when was the last time you watched this video in the offset, well, then we can go to the table and say, for this user and this video, just give me the additional information here. So once again, we're able to do very fast lookup to grab the last time you saw a video, so we know where to pick up. We can actually do a filter the last number of days. So if you wanted to say to us, what is the last 10 videos that you have watched? Well, they're sorted here by timestamp. So we could go to the table and say, for a particular all videos by in the last 10 days, for example, for the timestamp, and then the system would return that back to our virtual machines, which then we could put it into a grid and then return that HTML back to you so you could go and see it. And the virtual machines, they can offer things like sorting or time, or in the future, we would add another property here for rating. That would be how you rated that particular video. And then on the website, you would be able to click and say, well, let me see the videos I've watched in order of their rating, right? Or videos I've watched in order by the time stamp when I watched it, most recently to least recently watched. Or maybe you just want an alphabetical list of videos. So all of these things are very easy for us to calculate or compute and give back to you because of the way that this table is designed. Now we have this bookmark table. As I mentioned earlier, you're able to go and for any video you're watching, say at this offset within the video, I just want to put some kind of note. And of course, within a video, you might have a couple of bookmarks for a single video. So we have this bookmarks table. And similarly to the watch video table, the partition key is the user ID. So that means they're all grouped together in the table by your user ID. And then the row key is the video ID. So if you go to a particular video, we can easily get, here are the bookmarks for this particular video for this particular user. We have timestamp information here, so we can see which videos you've created bookmarks for most recently. And then we have a bookmarks property. Now, the bookmark property is a little bit interesting. So for any given video, you might create no bookmarks. You might create 5, 10, 15, 20, 100 bookmarks. And each bookmark has associated with it an offset within the video and then a string note. So what we do is, in our service, we have a collection of all of these, and then we serialize them all into a byte array, and then that byte array makes up this one bookmarks property that's in the table. So we always look up for any video. We always get all the bookmarks for that particular video with one I/O request out to the table service. So as you can see from the notes on the right, that the bookmarks table is grouped by user and video. It's easy for us to look up all bookmarks for a particular user or all bookmarks for a particular video of the user. And we can also filter, so where have you modified bookmarks for a video in the last 10 days? We can do that timestamp filter in order to get that information back. And then the last one here is the user video queue container. As I said a number of times, we have a container, and in it we have one blob per user, and that blob contains your video queue. And the name of the blob is based on the user ID. So why is this in a blob where everything else is in a table? So here's some core concepts. When you can, you should put data into a block blob. There are several reasons for this. First, blobs are cheaper than tables. Okay, that's number one. Two is when you're getting and setting blob data, it's sent over the wire in binary fashion. But when you are getting and sending table data, it's sent over in UTF-8 text. So that means you're sending less bytes with blobs, and you're being charged for ingress and egress in some cases. And it's going to be faster, because you're sending bytes rather than UTF-8. So it's less data, which means it's going to have lower latency. So whenever possible, and you're thinking about, should I put this stuff in a table, should I put it into a blob, your go-to default answer should be blob. So when is a blob not good enough? Well, a blob is typically not good enough if you want to do filtering against data. So you have a lot of data in there, and you will need to look up a particular thing, or you need to get a group of things, or a collection of things. That's when the table starts coming more into play. And when you put things into a table, tables sort those things by partition key, row key, order. And then it can do fast lookups with partition key, row key, but of course the lookups are much slower if you do a search not specifying the partition key and row key. So we looked long and hard about putting the user's video queue into a table. We said, why don't we just create a table, and in the table, the partition key can be the user. Now the row key, if we made the video ID, then they would be sorted in video ID order. But the user really wants to maintain control over the order of their queue, right? You want to have the ability to resort videos that you put into your queue so that you'll watch them in the order that you desire. So then we said, well, so it doesn't make sense to put them into a table with ordering because the order is really by the user. So once we got to that point, then we said, well, if the user is going to have complete control over this and it's an arbitrary amount of data, and because blobs are cheaper, then we should really be putting this information into a blob. And also, another thing that we considered when discussing this is that the queue is basically read all or nothing, right? When you go to look at your queue because you want to put something in it or take something out, you want to see the whole queue, right? You want to see all the videos that are in your queue, typically. So by putting into a blob, we read the entire blob contents out. We can say, here are all the videos in the order that they have them. You can change that order. You can delete things. You can add things, whatever. And then we just write the whole thing back out to a blob in the order that you last specified. So it really was the fastest, easiest way to do this and gave us the most amount of flexibility. So as I say here, the things that we considered were the queue items are manipulated all together, right? We don't manipulate individual items in the queue typically. So we can do adding and possibly adding to end if we append something to the queue. We can remove, and we can remove from the beginning or middle or from the end. We usually show you all the items in your queue all at once, and we want to give you the ability to order them all in the queue. And so a blob for this makes much more sense than using a table. And again, it's cheaper and faster on top of that. Do you have to use PayPal? What if you give members payment choices where you store their payment details? So when we first launched the service, PayPal was the only thing that we offered. There were a lot of reasons for that. First of all, we knew we didn't want to do credit card processing ourselves, and we didn't want to take credit card information. We didn't want to have the burden of security. So PayPal was a well-known entity that a lot of people were familiar with, and they accept money in lots of different currencies around the world. So, and it's a well-respected service, it's been around for a long, long time. So these were all the things that we considered. Now, after we went live with PayPal, we did have some people who didn't like PayPal or couldn't use it. I know in particular there was a problem with PayPal and people in Germany we had a bunch of issues with. So what we decided to do, this is a few months ago, is we added Stripe support. So now, no, you don't have to use PayPal anymore. And in fact, we're trying to actually discourage people from using PayPal now and to use our Stripe support instead. It's actually, Stripe is really better fit for our service than PayPal is what we've now learned. And so now you have the option. Next, how can a user search between the bookmarks of more than one video since the data is serialized? Isn't loading all records and deserializing the data slow? It is true, the only way that we can allow a user to do a search for terms that are in the notes of their bookmarks is we would have to load all of the entities for that user and then deserialize all of these offsets and notes in order to do the search. So first of all, I didn't offer that feature, and that's the reason why we don't offer the feature, is because it's a fairly expensive feature for us to offer in terms of latency and work that has to be done, right? In terms of performance, it's kind of expensive for us, so we don't offer that right now. If we get more feedback from customers that it's a feature that they would really like to have, and to date we haven't gotten that feedback, just for the record, but if we get that feedback, then we're still set up to do it. And it would cost us a little bit of perf in order to do it because we'd have to deserialize this. But there's really, Azure Storage doesn't offer a search mechanism. The only way we could really do the search on the server is if we had separate rows in the table. Well, there's really no way to do it, actually. So if we had, you could think that we have separate rows in the table, one row for each bookmark. Right, and then we could have multiple rows that are the same video ID. But even then, the note itself would be a property, and Azure tables don't support the ability to filter on words within a string property. So we would still have to go and get all of the rows from the table so that we could do that ourselves on our virtual machines. And then, if that's the case, then what we have here is actually better. Because now I can just make one request to get all the bookmarks for video instead of multiple rows with bookmarks, with multiple bookmarks for a single video, I can now get all the bookmarks for a single video. I have to deserialize that, and then I have to do the search. So we've thought about it. Azure storage tables doesn't provide a good solution for doing like plain text search within properties, string properties of a table. So we can't leverage them doing it at all. So we have to do it ourselves on the client side in our virtual machines. And we can do it using this architecture right here. And we'll add that feature when we get enough client requests to do it. We have other things that are a higher priority for us in terms of adding features. Like ratings, I think we have a higher priority item than this. Is this the one I just read? I think it is. Yes. Okay. So now we've got our infrastructure. When we first built this system, we didn't really have very much logging at all. And then over time, we said, well, we need to remember that this thing happened, so let's just create some kind of logging code. And then it came up again, and it came up again, and it came up again. So the next thing you know, we had all this logging code that was sprinkled throughout the system everywhere. So then we did a re-architecture of the system. We said, look, logging is critically important, and we want to make it a first-class citizen. So we came up with some class library methods that are part of my NuGet package, or will be part of my NuGet package in a month or so, as I said. And we now have this formal logging infrastructure. So whenever we want to create a new log, type of log in our system, we just new up another one of these classes. We specify some parameters to the constructor, and then anywhere in the code where we need to write to the log, we just call, I think it's append async is the name of the method, and it just appends some data out to the end of the log. And it's just super simple now, and it has all kinds of date support and things like that. So let me talk a little bit about our logging infrastructure because we found it so incredibly valuable. First of all, we log everything to blobs, not to tables, for largely the reasons that I just said before. Blobs are cheaper than tables. They are faster than tables with moving data in and out. Also, blobs, you can easily download a blob onto your machine to load it into tools. Like we're constantly loading these log files into Excel, and then we use Excel to create charts and graphs and so on. So downloading entities from a table into a file on your hard disk, there's like no easy way to do that and then to look at it. So we use blobs for our logging. We don't use tables at all. Our logging infrastructure is best effort. It's not guaranteed that every single entry will be written, but I mean, it's 99.999% chance that the entry is going to be written. The only time it wouldn't is if for some reason the service gets an unhandled exception, or if Azure decides to recycle the virtual machine or move it to another physical machine for some reason, or bring it down in order to update the operating system or the guest agent. So that's the only time entries would be lost. But I do want to say that the logging does not guarantee that the logs are actually going to occur. But the likelihood of failure is minuscule. The logging is all done asynchronously. And this is done to allow quicker response to the user. So, for example, the user starts watching a video, and we need to put our entry into a log saying on this date, this person in this video. So the person in the video reading, the watching, then we're back on it. So it's active format. But an administrator is adding or removing grantees from the seats that they're paying for. He can give a response to the screen, but again, that's happening asynchronously in the background. The user is working with the fast, very simple underneath. We have a log. We identified the use. The first kind of log, and we have this log again. We're using now. If we want to the log, we have a log. And there's one code the information shown in the log. Now, your log will have a list these blocks, and another log put in the log. So this log fits everything we do, so leave from the beginning. But for a lot of our things here, 50,000 entries is simply enormous. Like 50,000 promotional codes, we would have to have 50,000 people registering with the system using a single promotional code, because we create one of these blobs for each promo code that we have on the service. So we should be so lucky to have 50,000 people registering with one promotional code. That's what I would have. So the 50,000 is not for us. We have a problem using this policy. Have problems with zero people. We also have account management operations. So there's one of these ongoing blobs or logs for each account. And whenever a user is granted access or revoked access to accounts, we manage for each. So over the course of an account, we remember the last 50,000 operations that have happened to that account. Again, we enormous. If you're I mean, that could take years, I would think. If we're doing stuff to read, and I can't imagine an administrator would say, hey, 10 years ago, who was in seats? But again, if that's not being a problem, we can fix that too, but we don't anticipate it for a decade or more. The alternate log we have is a periodic log. The periodic logs are dated, of course, and we created one. It supports creating one of these every day, so it would be a daily one. And we use that for our error handling. Whenever an unhandled exception occurs, we create a log that day, and we pending any handled exceptions for that day in the log. And then hopefully we would date out unhandled exceptions, and then those logs would be mixed for the which is great. We love it. We love them. We can also do a weekly periodic one, or a monthly one, or a yearly one of these. As I said, we use it for errors right now, just delay. And we have the account user transcript. Whenever a grantee gets to watch videos under an account, we record into a blob that on this date this person watched a video. So the administrator can then say who's been watching videos and how much. Again, we do the monthly, which is related to the billing cycle. And over here, I mentioned about the garbage collection aspect of this. So because we're creating a new one of these every month on the bill cycle, we said we're only going to keep the last 6 months. Anything older than that, the code will automatically destroy those blobs and delete them from the system. So we're not paying for that storage indefinitely as time moves forward. And this is my last slide here. And then I can just take any questions that you might have. A couple months ago, there was this story of a company called CodeSpaces. And if you haven't heard this story, I would highly recommend that you do a web search for this CodeSpaces company. And it quite literally it scared me. It scared me a lot. So what happened was this is a company, and they were running their service, and they happened to be using Amazon Web Services, but it really doesn't matter who they were using. And they were a source control service. So customers, like you and me, we would register with them, and then we could put our source control for our projects into this service. Well, some hacker out there found out the password to their account on Amazon, and they left messages for the owners of the company that if they don't pay up, like millions of dollars, I don't know what this sum was, but if they don't pay some amount of money, that the hacker was going to go and start deleting files out of the service. So then when people logged in, they saw that the hacker left these messages, and they started wanting to protect their data as soon as possible. So they started doing things to protect their data, like changing passwords and so on. Unfortunately, the hacker noticed that that was happening, and the hacker then did start deleting all of the data that the company had. So now all of the data that was in storage for all the customers was completely destroyed, and nobody knows exactly what they weren't their data, properly, really. Well, I read that, and then I was thinking about so could a hacker get into our system and just delete all the data that's there? So first of all, you have to imagine, so what data do we even have that's worth protecting? We don't have really any personal information from people. We don't even ask for your address or phone number on this. We ask for it, but it's optional. You don't have. So people don't actually give that information to us. So what do we have? I mean, we have people's email addresses, and we have what videos you've watched, what videos you put in your queue, and some bookmarks. And is that confidential information? Well, I would say to some degree it is, and we consider confidential information. For example, you wouldn't want somebody at a competing company to be able to look up what videos employees at this other company are watching, because then that might get some insight as well. Look, employees at this company are watching a lot of videos about X, Y, and Z. Maybe we should be focused more on X, Y, and Z too. So we do consider that it is somewhat secure information, what videos you have watched on what date, what's in your queue, and so on. And we would like to protect that so that it doesn't get compromised in some way. So I've come up with this architecture for how to do data recovery and to manage your data. And actually, it was just yesterday I went to Microsoft and I sat down with the Azure storage team and just reviewed this with them, and they also think, yes, this is a great architecture to perpetuate and to have people use. So I'd like to explain this, and then we'll be done. Let me just see what the questions are here before I do that. Do you log changes made to all the tables by users too, like who changed what and when? No, we currently do not log that. That would be, well, first of all, for a particular user, that information can only be changed by the user themselves. So we don't think there's really a need to do that. I mean, unless there's a compromise in our code base somewhere that's causing that to happen, which we don't think that there is. But if there is, then the logging code could be compromised too. So we don't do that. I don't think it makes sense for us to do that. How do you handle an email address change if it's stored in two different tables, account and user? But I don't think there's a way to transaction across tables. Can they get out of sync? So, Peter, that is a fantastic question. And I have spent more time thinking about this particular problem than you could ever imagine. So that is our big Achilles heel in the system right now. You are correct. There is no way to do a transactional update across two different tables with Azure tables. So we do have a way that we make this work, and it's a little bit on the tricky side. So if the user is changing their email address here in the user table, first thing we do is we go and we get all the account IDs that they're an administrator of and the account IDs that they're a grantee of. So now we have to load in all these accounts. Well, and actually, first of all, if they're a grantee of an account, well, if a user is a grantee of an account, we don't let you change your email address. This is by design, because when a manager at a company puts, let's say, Jeffrey R@wintellect.com into a seat, and then as Jeffrey's watching videos, there's this log that's being created where the administrator can say, here are the videos that Jeffrey's been watching. Well, if we let Jeffrey change his email address, then that email address is what shows up in the log. So if I just change it to jeff@hotmail.com, then the administrator could look at the log and say, who is that? I don't know even who that is. So once an administrator has granted you access to an account, we forbid you from changing your email address. The administrator would have to revoke you from the seat explicitly. You'd have to be removed. Then you could change your email address, and then you could put you back in. So that way there's a handshake of this knowledge, and there's a tracking between the administrator of the account and the person who's in the account. So that simplified things a lot for us, and that was great. But if you're an administrator of an account and not a grantee, only an administrator, then we do let you change the email. So in that case, what we do is we create a new row in the user table with your new email address and keeping all this other stuff over here. That would all stay the same. We get your account information and we grab the email addresses here and then we change it to your new email address, and then we update the entry in the account table over here. And then we go and delete the old email address over here from the table. So the deleting of your old email address is done last. So if we get a crash in the middle of these operations, you actually exist in the table with your old email as well as your new email. And that allows you to perform this operation again, or we can roll it back. And this is how we make this changing of the email an idempotent operation. So there's a bit more to it than that I don't want to go into right now, but this is really the only problem where we have two entities in two different tables that we need to keep them in sync with changing data. And we thought a lot about how to deal with that. The slides are not available presently. I can take a look at possibly adding that or making that possible, but I haven't really thought about it right now. Let's see, this is a new question, or this is the old question? Oh, I see. It's maybe an add-on. Is it deficient? Okay, so it's gone. All right. So the last thing I wanted to talk about is this bad code hacker recovery architecture. So first, let me say that Azure has some built-in support for what people typically refer to as disaster recovery. Let me be a little more explicit. When we say disaster recovery, I would say we mean a data center disaster. So if a data center disaster occurs, like a meteorite hits a data center, or for whatever reason the data center goes offline completely, then Azure already has built-in support, because when you create a storage account, you can create the storage account using geo-replicated storage. So whenever you make modifications to blobs or tables in one storage account, Azure is automatically replicating them to another data center somewhere else on the globe. So should one data center go down completely, there is a copy of the data in another data center. Now, it's not guaranteed to be totally in sync, so you may have lost a couple minutes worth of data, but usually you've only lost a couple minutes worth of data, like maybe 4 minutes worth of data. So that is the built-in disaster or data center recovery that Azure has built in. But what I wanted to address was maybe you have code that's bad, and your code accidentally deletes some data or corrupts some data. Or let's say you have a hacker who's hacking your system, and they want to go and delete the data. And when I say hacker, it could be that you have an employee that you lay off or fire for some reason, or has a bad day, and the employee wants to go and attack the site and corrupt the data. So even an employee who's been with you for a long time could potentially turn into a hacker at some point in the future. So I wanted to come up with an architecture that really protected our data. So here is the architecture that I've come up with. So first you have your live site account. So this is your Azure account that you use for your live site. In this account, you would create 2 different subscriptions, and you would put them in the same data center. One subscription would have your cloud service virtual machines, and another subscription would have your storage account in it. Now, the reason why these are in different subscriptions is because you want to give developers the ability to roll out new code into the virtual machines and to upload new versions of the code. But if you put the storage account in the same subscription, and if your developers have access to the subscription, then the developers within your company have access to all the data. And then they could go into the tables, and they could read the data, they could modify the data, and it's not really secure enough to do that. And then, as I mentioned here, on that storage account, you might want to use globally replicated storage or possibly read access globally replicated storage, because this is the mechanism Azure provides for doing data center recovery. Now, on your cloud service virtual machines, there's a CS configuration file. This configuration file has a bunch of key value pairs, which are setting names and setting values. And then your virtual machine code can read these configuration values. And what a lot of people put in here are connection strings to storage. Now, if you put the connection strings in the CS config file directly, when your developers go and upload the new code, they also upload the CS config files. And if you put the connection strings to storage in the CS config files, then again the developers have access to the storage account. And you really don't even want your own developers to have access to the storage account. Right? There's security ramifications there. You're opening yourself up to a disgruntled employee being able to delete everything in there. There's a lot of negative stuff. So when you put your connection strings, storage account connection strings, in the CS config file, you really want those to be encrypted. And then you give the encrypted versions to your developers, and then they have only the encrypted thing. So now they would need to decrypt it. Now, to decrypt it, the best way to do this is by using what's called cryptographic message syntax, or CMS. And if you do a web search for it, you'll see there's this cryptographic message syntax, and this is really probably the best encryption decryption mechanism that you can use to solve this particular problem. With the CMS, what you do is you take a string, you encrypt it using a certificate, then you upload the certificate to the Azure portal. When Azure creates the virtual machines, it will install the certificate on those machines. And then when you grab the encrypted string out of the CS config file, you can go and decrypt it, and it will find the certificate, decrypt it, and now you have it, in clear text on the virtual machines itself. Meanwhile, the developers in your company, they only ever see the encrypted string, and you don't give them the certificate so that they cannot decrypt the strings themselves. All right, so now as your service is running, and you're putting things into storage, you need to do backups of blobs or tables periodically in case you have a hacker who wants to go and modify some data, or you have some bad code in your service that's going to go and modify the data. So you need to have a backup periodically that you can go back to in order to restore back to good data. So here's how we accomplish this. We use this periodic elector that's part of my NuGet package, and that's there today, by the way, so that exists. What this periodic elector does is it's a piece of code that runs on all the virtual machines. And let's say at midnight on Sunday, all the virtual machines say, I want to back up the data, I want to back up the data, I want to back up the data. And the periodic elector coordinates across those machines to pick one of those virtual machines to be the winner. So one virtual machine becomes the elected winner to do the backup. And all the other virtual machines in the cloud service, they just continue processing client requests. So now that one virtual machine is chosen as the elected winner, it now goes and takes any blobs that have been modified since the last time we've done this, and it writes them into another storage container. Now this, or storage account, writes it into another storage account. Now this storage account is usually in the same data center because that makes it fast and it means you're not egressing data, so that makes it cheap too. But it would be in a different account because you don't want to put these, you don't want to put this in the same account as the stuff on the left, because if your account credentials ever get compromised, it's a single point of failure for everything. So you really want to have a separate account for your recovery data, and you want to keep that username and password very close to your vest, right? You keep it close to your chest. You don't want to give that out to anybody. So the periodic elector is going to write this information that's changed into storage. And I also have a part of my NuGet package where there's a function that can scan a table and it grabs all the entities in a table and serializes that into a blob. So I'm copying the table entities also into blob storage here. Now, the way that I do that, I don't want to take this storage account and take its keys available on this system. If the keys for this storage account runs here, then if the system on the left gets compromised, then somebody could get the storage keys and go into the recovery account and then delete everything there. So in order to really protect the data in the recovery account, I want the data to be write-only. I want it to be non-deletable in any way. I want it to be write-only. So the way that I accomplish that, and I don't want to expose the keys, because the keys would make it read-writable. So the way I accomplish that is, on the container that I create in here to back up the data, I create a shared access signature for it. And that shared access signature will have write-only access to it, and it never expires. And that's what allows, and I give that shared access signature to the machine on the left, right, the virtual machines on the left. And then they're able to write into the storage account. And since the shared access signature is write-only, they can't do delete. So then you might say, but Jeff, if you have a blob that you wrote into the storage account, and you do have the machines on the left get compromised, and they get the SAS that has write access, then couldn't we just delete whatever gets written into a blob after the backup has occurred? And the answer to that is yes, that could happen. So the way that I mitigate that problem is after a backup of a blob has occurred, I snapshot the blob. As I say here, I snapshot the blob. And once you tell Azure to take a snapshot of the blob, then the blob's contents can never be changed. And this is how I protect this data, so that we always have it, and we can keep multiple blobs with different dates for different backups, all in that account. Now, at the top here, I have a utility that we wrote, and that utility periodically modifies storage keys and rolls them over, and modifies the SAS periodically. It basically, we can run this utility hourly or daily or weekly, whatever we want. We can run it whatever we want, or if we fire an employee or lay an employee off, we can write it right then and there. That resets all of our account key information to protect all of the data. And we just made this a utility that we can run whenever we want to, so it's super easy to do. Now, this has to be run by a highly trusted person at the company. So typically it would be me, because I would have access to the certificate that's used to encrypt the storage account keys. So very few people have access to actually run this utility. It would be somebody who's highly, highly, highly privileged at the company. But then everything else runs and flows smooth, and that's how we would protect all the data. All right, on that note, it's 12:38. I think I went overtime, actually, and I didn't think it was going to take this long. Are there any final questions anybody would like to ask? Yeah, my last slide is the question slide. Is anybody there? Did I just talk for hours? Nobody could hear me?
Actually, we're here.
Okay, good. Because that would be really bad.
That was a great presentation.
Went on.
Well, it doesn't look like there's any questions now. I think that we really want to thank you, Jeffrey. That was a really excellent presentation. I kept commenting to Peter about how it seemed like when the people were asking questions, you were suddenly talking about that anyhow. So that was good prep and a good topic because they asked questions like that. I think that we all learned a lot here, and I frankly was surprised about your blobness statement, but it sounds interesting.
About which statement? Which statement?
Oh, you know, everybody's always said blobs were heavy, and the way you talked about it, right after the question came to my mind was exactly the right answer. I thought that that was an excellent way of saying that. And thank the audience for showing up too. You know, you guys showed up, and you know, we'll have this recording, so any of these questions that you have, we can you can go back and look at the recording in a day or so that we post to YouTube, and you'll be able to answer the question maybe based on re-listening to it. We've had quite a few.
Okay.
And quite a few people looking at our videos online, so I think that that's great that you did this because it's some pretty excellent stuff. And we thank you. And we thank our sponsor, Sync Fusion, and I guess that's it for now.
All right. Well, thank you very much. I was glad to do it.
Thank you very much, Jeffrey.
Okay. Thank you.